Okay, let's look at practice D, and we're going to look at projectiles launched horizontally. So let's look at number 1. So when we're doing two-dimensional kinematics, when we're doing projectiles, whenever we're writing our given, we're going to separate our x and y given. So I'm going to have my x and I'm going to have my y. Okay. The first thing we're going to write for every problem is ax is 0 because we know there's no horizontal acceleration, and g is equal to negative 9.8 meters per second squared. Okay. The next thing I want to do is I want to read the problem and draw a diagram. So it says a stone is thrown horizontally at a speed of 10 meters per second. So that means the initial velocity, VI, is equal to 10. But it's thrown horizontally, so that's important. 10 meters per second from the top of a cliff, 78.4 meters high. So I want to find A, how long does it take the stone to reach the bottom of the cliff, the time, and then B, how far from the base of the cliff does it strike? So I want to find X. So first I'm going to draw my picture. Okay, so remember our frame of reference, we're going to use the same Cartesian sign convention like we use in math class. Up and to the right is positive. And the origin of the graph is the origin of motion. So where motion begins is our frame of reference. So when VI is equal to 10, it's going to go like this because we know that gravity is going to pull it down. When they tell us that Y is negative 78, we're measuring from here down, so Y is equal to negative 78 meters. So in our given, if we are given the initial velocity, we want to break it up into horizontal and vertical components. But this is only going horizontal. It has no vertical components. So VIX is equal to VI, which is 10, and VIY is 0. And I'm going to write that down because it's important. And then I know that Y is negative 78.4 meters. We got the 0.4. How do I know where to begin? We know that all of our kinematic equations have 4 variables. There's 2 here, and there's 3 here. So wherever there's 3, that's where I know where to start. Okay? So I know that I have G, I have VIY, I have Y, and I want to find T. So now I'm going to say which equation has those 4 variables. So that's Y is equal to VIYT plus 1/2 GT squared. Because VIY is 0, that whole term goes to 0. So I know Y is equal to 1/2 GT squared. Now we're going to rearrange the equation to solve for the unknown in terms of the known. So I'm going to multiply both sides by 2. So I have 2y is equal to gt squared. And again, you can do some of these intermediate algebra steps in your head. Then I'll divide by g. And then I'll take the square root of both sides. So the square root of 2y over g is equal to t. So I substitute in my values. 2 times negative 78.4 meters divided by negative 9.8 meters per second squared. So I see underneath the radical, the negative in the numerator cancels with the negative in the denominator, and I end up with a positive value for time. If I look at it on my calculator, again, I would say 78.4 negative times 2 equals divided by 9.8 negative equals, and I take the square root, 78.4, I'll just do times 2 equals divided by 9.8 equals square root, and I get 4. Okay, for part B, now here's the thing. Once I find the time on this side is 4 seconds, the time on this side is also 4 seconds because time is scalar, so the time is going to be the same. Now we want to find x, so I'm going to come down here, so from here over, that's going to be x. So now, to do that, I know ax is 0, vix, t, and now I want to find x. So I'm going to say which equation has those 4 variables. Well, our basic equation is x is equal to vix t plus 1/2 at squared, and this is ax. We know there's never any horizontal acceleration, so this is our equation. So it's going to be 10 meters per second times 4 seconds is going to be 40 meters. And that's our horizontal displacement. So that's number 1. Again, you want to separate your x and y givens. You want to, where motion begins is your frame of reference. You want to draw a diagram. And remember that here, VI is equal to VIX because it's all horizontal. It has no vertical component. And that's it.